Hello, everyone. Welcome to this meetup. I'm Matt from VeloDB, and I'm also the PM's member of Apache Doris. Thanks for AWS for this place so I can share some insight on real-time data warehouse for AI and analytics. Uh, Firstly, I want to introduce my company and the Apache Doris community. Apache Doris was a real-time data warehouse project in Apache Foundation. And during 10 years of development, it has integrated many good features from other systems. For example, ClickHouse, Trino, and Elasticsearch. And currently, it has received more than 13,000 stars from GitHub. And our company, VeloDB, is a commercial company to provide and build on top of App Stories. We provide some commercial service on cloud and on-premise service. And we also committed to provide technical and user support for our customer and the community. Apache Doris was built on 2013, so it already has more than 10 years history, and it was open source in 2017 and I graduated from Apache Doris Apache Incubator in 2022. And currently there are more than 600 contributors in the community and more than 100 active monthly contributors. Since 2022, Doris community moves very fast. For example, we add many modding features to the project. For example, cost-based optimizer, pipeline execution, and for vectorization, and inverted index, and more. All the features in the yellow box is contributed by our company. And currently, as far as now, there are over 5,000 enterprises worldwide adopt Apache Doris in their core data analysis scenarios. For example, some big brand is the Post Saving Bank of China and China UMS and Lenovo and Anta, the very large clothes brand in the world. And second, I want to introduce some key features of Apache Doris. And the first feature is real-time data ingestion. It is very important for real-time data warehouse. You need to ingest data from the online transaction system into Doris, into the OLAP system very quickly, so you can get the real-time insight from the system. For example, Apache Doris could scale up to more than 200 backends or data nodes in the system, and it can serve about more than petabyte data in the system. And when our customer is Minimax, it is a GenAI company in China. It stores more than 10 petabytes logs in Apache Doris, and the ingest speed could up to more than 10 gigabytes per second. And in our test, we find we can ingest data more than 50 megabytes per second in one thread. Besides the real-time ingestion, we also provide some transaction logic to make sure the data is not lost and the data is not duplicated during some failure. Beyond real-time data ingestion, we also provide blazing fast analytics capability. For example, in ClickBench is a very famous benchmark in white table test. We gained the top three ranking in the past year, and we also beyond the white table query, we also put at very complex join queries. For example, when our customer provided me a very complex circle, the circle has more than 10,000 lines. It's very complex, and also in TPDS benchmark, for example, TPDS 1 trillion data. Doris Lakehouse Analytics outperformed the Trino more than 3 times. Doris could also behave as a high concurrency queries. For example, in JD.com, JD.com is a very big e-commerce company in China. Its GMV is more than 4 trillion RMB 1 year. It saves more than 10 billion records in Doris and serves more than 10,000 queries per second, and the average latency is about 150 microseconds. Beyond the data warehouse, and the Doris is also a lakehouse platform. We provide multi-catalog feature. You can use multi-catalog feature to mapping the metadata from other external systems. For example, you can mapping the data in Hive, Iceberg, and Python, and some RDBMS systems like MySQL, Oracle, Redshift to Doris. And after the data is mapped after the metadata is mapped in Doris, you can query the external table very easily, and we can accelerate the data query. We will see some data cache in the local disk of the backend node of Doris. And the user also could do some ETL and ELT jobs on top of Doris. For example, in Cisco WebEx, they use Doris to simplify their big data stack. In the past, they used ClickHouse, Elasticsearch, and HDFS, and many other systems to build their big data stack. Currently, they can use Doris to replace them and reduce the cost by more than 30%. And also, NetEase is the second largest game company in China. They use Doris to replace their Trino stack to perform lakehouse query, and they gain more than 10 times faster than before. In addition to structured data, Doris also provide semi-structured data analysis capabilities. We add an inverting index and n-gram Bloom filter into the system. So user can query the data, use the like keyword, and we can use the inverting index like Elasticsearch to query the data very quickly. And also, more and more JSON data is used by the enterprise. We also provide the variant data type to store JSON data very efficiently. We will decompose the JSON data into a column format. So the whole data will have a very high compression ratio and a very fast analysis speed. For example, we save the ClickBench data. The raw data is about 70 gigabytes, and we save it in a very big JSON. In JSON format, it is about 35 gigabytes, and if we save it in variant type, it is only 12 gigabytes. And also, we run the total 46 ClickBench queries on top of the data. And the variant data type is about 10 times faster than JSON data type. And many companies in China has replaced Elasticsearch with app stores. For example, the TrueWatch, the Best Pay, and the ZTO Express. For example, ZTO Express is a very large logistic express company in China. They use Elasticsearch in the past to do invert index for the MySQL data, and currently they move all the data from Elasticsearch into Doris, and they can use SQLite dialog to query the data, and it's also 2 times faster than Elasticsearch. Beyond these features, Doris could also integrate with other components seamlessly. For example, we provide MySQL compliant interface. Current data BI and visualization tools could query the data in Doris directly. For example, QuickSight, Tableau, and Superset. And also Doris integrate with other transformation and orchestration frameworks seamlessly. For example, the Citano and the Visual Studio framework. and and other data stream frameworks, for example, Kafka and Confluent, and other streaming networks frameworks. The next part, I will introduce the strong data foundation for GenAI. In this picture introduced by Pengfei before, we can see the open data lake. We can ingest open data lakes to the data in open data lakes into VeloDB or by using Visual Studio or VisualOps, and then we can build a vector index in Zealous, and then we can provide GenAI features or LLM queries based on Bedrock. Okay, let's see a high-level view of the GenAI framework. If the data is injected into a VeloDB or managed by VeloDB framework, we can get the metadata and the history query data from VeloDB, and then we can embedding the metadata and query history data using Bedrock embedding framework, and then we can get some vectors, and we can save the vector in the vector database, Zealous. When the user give a prompt, we can use the embedding framework provide Bedrock to get a vector, and then we can do some similarity search in the vector database to get some candidate queries or metadata. Then we can use the Bedrock Titan framework to organize the query and generate the query so that we can retrieve the data from VeloDB. So that VeloDB play a very important role in the GenAI. Firstly, it provide a unified data management framework. It can integrate data silos and provide data security and governance feature. For example, you may have data in RDBMS like Redshift, MySQL, and PostgreSQL, and also many data in open data lakes on S3. For example, Iceberg Data Lake, Pymon, and unstructured data and many files or logs. And VeloDB already integrated with Ranger, so that when we provide centralized administration and standardized authentication and centralized auditing of admin. And also we are integrated with Atlas to provide data governance features. VeloDB also empowers data prepare and data process stage in GenAI or RAG framework. We can do rapid batch processing for all data. We can do spell disk and in-memory data exchange like Impala, and then we can do spell disk like Redshift or Spark to do very large data processing. Beyond speed, VeloDB also provides various storage and computational optimizations for semi-structured data, such as JSON complex data types like strings, maps, and arrays, and structures. We also have a UDF framework. You can write your own UDF in Java or C++ to optimize the performance. We also have remote UDF so that you can write a simple code in your server, and we can call this function by using remote procedure call to get the result. And the most importantly, I think VeloDB provide a blazing fast online data retrieval. We have vectorized the processing engine and async and synchronized view. You can accelerate the data retrieval transparently. And more, I think the quality evaluation and observability is also very important. For example, during the long-chain model training and inferencing process of MinMax, a large amount of logs were generated. The regional graph in the past they used Grafana and Loki based logging system had performance and stability issues. After switching to the log system based on Apache Doris, it can handle more than 10 petabytes data with availability of more than over 99.9%, and the query latency is about 100 is less than 100 microseconds. It is efficiently solves the data processing problem. And also, VeloDB provides very flexible usage scenarios. You can use VeloDB on VeloDB Cloud. It provides build on your own cloud service, and it is also a SaaS service. And you can also deploy VeloDB Enterprise in your own data center. It is very secure. It can deploy it on your virtual machines or your Kubernetes clusters. Okay, my speech is very short. Thank you. You can join our community by scanning the QR code to join the Slack or WhatsApp community. Oh, thank you.